This video is going to cover how to do one-sample hypothesis tests of means in R. Just like in all of these tutorials, I'm going to be using the 2016 wave of the General Social Survey that you can go grab online. So I'm going to load the data, and then we're going to just get right into how to do the test. So the basic command is the t.test command. And from there, all that you need to do is just put in the variable that you want and then set the parameter value, and then you can basically just run the test. So in this case, we're going to be using the variable eduk, which is the years of education for the respondent. And what we're going to do here is test and see whether the respondents in the GSS are more educated or less educated. This will be a two-tailed test relative to the general population. And if you go and you look up in something like the census, which gives us our necessary pseudo-population value that we'll use in our one-sample test of means, then all you need to do is just type in mu is equal to, and then the value. In this case, I went and I looked, and it was 13.2 years of education, right? So we're basically, just with this little setup, going to be seeing whether the respondents to the GSS are more or less educated relative to the whole population, which might have implications for things like political views of the respondents and so on. So once you've done that, just run the test, and you will see that R produces this, this output for you. So first, it's telling you the variable it's working off of. This is the statistic associated with your test. It's scaled in t, but since we have a lot of degrees of freedom, you could interpret that as a z-score 2 if you want. So here are what we might call a t-obtained statistic. The statistic attained from your test is 9.6901. And we have 2857 degrees of freedom, which is the total number of non-missing values of education, minus 1. Then we have our p-value for the test, which is very small, 2.2 raised to the 16th negative power. And then you can see right there that it's telling you the alternative hypothesis, which is also sometimes called the research hypothesis, and that it's not equal to 13.2 for the subpopulation of GSS responders. And this is what tells you, by the way, that it is a two-tailed test rather than a one-tailed test, which we'll get to in just a second. Here's the confidence interval for 95% around the mean of education for the GSS, and then R also just gives you the value that you're working off of. So here, the mean educational attainment is 13.73 years, which is obviously bigger than our mu value of 13.2. And so you can see that at any kind of common level of statistical significance, this test would certainly meet that standard. So if we wanted to compare our t-statistic to our widely used plus or minus 1.96, you can see that this t-obtained is clearly bigger. Or you could also just compare your p-value, which is very small, to an alpha value of something like 0.05 or 0.01, or whatever arbitrary value you happen to be using. And that's the basics of the test. The other thing that's worth mentioning here is that you don't have to use two-tailed tests. So I'm going to just copy and paste this line and then move it down here. And now I'm going to start using this optional argument called alternative, which will allow you to set whether you want a one-tailed test or a two-tailed test, as well as to set the specific direction of where you want your error to fall in the one-tailed version of this. And the way that you would set it is just type alternative, and the default, so you don't actually need to do this, is 2.sided, right, for the two-tailed test. But instead, let's say that we wanted to check whether the GSS people were more educated relative to the population as a whole, then you would just put in greater. And so I'll just flag a comment here for mu subpop is greater than mu for the whole population. And so since that's a comment, R is not going to pay attention to it. And I can run this command, and you can see that actually not very much changes. Your t statistic remains unchanged, of course. Degrees of freedom are unchanged, p-value is unchanged, but now we're testing a very specific alternative hypothesis that the true mean for the subpopulation is greater than the population mean of 13.2. The confidence interval now goes all the way up to infinity because we're not paying attention to that. And that's basically it. If for whatever reason we wanted to flip this around and test whether the mu for the subpopulation is less than the whole population mean, which is obviously not right here, then you can just replace greater in quotes with less in quotes. And if you run that, you'll see that in this case, the test is of course not statistically significant because we have a very large positive result, which is not at all falling on the negative side of the curve. And so in this case, you wouldn't really think that there would be any reason that the sample of the GSS, that subpopulation is is less educated than the population as a whole, right? And really, that's all that there is to doing these tests. The only other thing that I'll note is when I'm doing these myself, I like to create objects just to save them so I can pull up the test at any point. So I might take line 8 and copy and paste that and turn it into something that says eduk test gets the result of this, and then you can run it, and it doesn't look like anything happens, except now you have a new object in your global environment, and you can refer to that test whenever you want. So if you want to do all of your tests at once and then check the results, you can just do it that way. So just assign the test an object name and then type the name in, and then you can see the result. Not strictly necessary, but I do find it useful.